Good morning, everyone. I'm here to talk to you about discontinuous electrification. I'm going to be looking at it from a slightly different perspective to Marie. I'm going to be pulling back from the detail and looking at it as a system and seeing how discontinuous electrification has to be part of a wider railway system and how you have to think about it systematically. I'm not going to be offering any easy answers this morning. I'm going to be raising some questions and some considerations for you to think about, and really teeing up the breakout session that we have coming up later this morning. I've called it I Don't Mind the Gap, slightly tongue-in-cheek, because I think there's a perception in the industry that I'm a battery train skeptic, so I just want to use this morning's session to correct that view. I think we need to embrace this technology, we need to embrace the opportunity, but we need to do it in a realistic way and in a systematic way, and that's what we'll be discussing this morning. So, what am I going to talk about? First of all, I'm going to attempt to define discontinuous electrification. We're going to talk about different types of discontinuity. I'm then going to try and break it down into 7 modes of discontinuous electrification. We're going to talk about whether DE should be temporary or permanent. By the way, I am going to be calling it DE because discontinuous electrification is 11 syllables, and I've only got 25 minutes. So that's my contribution to the railway acronym salad, DE, all right? Is it temporary or is it permanent? We'll be talking about that. I'm going to talk about the feasibility of DE and some of the compromises that you make, because with any engineering choices, there's always inevitably compromises, and there certainly are with discontinuous electrification. All the way through, I'm going to be weaving in what I consider to be the forgotten customer, which is freight. A lot of talks, I'm sure you've been to talks on battery trains and things like that before, but typically they're either from technology promoters like train manufacturers, or they're from people like Marie looking at a specific system. I'm going to be looking at it systematically, and when you look at railway as a system, you have to think about freight. Freight is an important factor, so we'll be talking about that as well. And then I'll finish with attempting to set out what I think are some appropriate use cases for DE. So the question is, what is discontinuous electrification? It's worth remembering that it's a pretty new concept. And if you go back 10 years, almost nobody was talking about this. It wasn't a thing. We were all busy delivering conventional electrification in CP5. Other than, obviously, there were starting to be plans for core valley lines, but they certainly weren't fully developed at that time. So it's quite a new thing. But what actually is it? I've not actually seen anybody attempt to provide a written definition of discontinuous electrification. So within Atkins Realis, we've attempted to do that, and I'm going to share with you now what our definition is. So I'm going to put it up on the screen. I'm not going to read it out to you because I know you can't read and listen to me at the same time. So I'm just going to let you read it, and then we'll talk about it. Right, so hopefully you've had a chance to absorb that. Let's just break this down. First of all, it's a lot of words, isn't it? It's a lot of words and 4 footnotes in a definition. Those of you who know me know that I pride myself on communicating complicated ideas in a simple way that anybody can understand. I'm not very happy with this definition. This is about version 5 of the definition. There's a group of us been working it, and every time we write it down and think we've got it right, we realise it hasn't captured some other mode of operation. So we're not very happy with this definition, and the challenge to the room is, if you've got a better definition, you think you can write it down, then please do and send it to me or let me know. I'm very keen to try and improve on this. The reason why it's such a word salad is that we're trying to encompass all the different possibilities within decarbonisation and electrification. And it's worth saying as well that battery trains are electrification, right? I often see that battery trains set up in opposition to electrification. But battery trains are a form of electrification, and you'll see why it's really important that we bring those 2 ideas together as we go through the challenges that we face. So we wanted to scope the definition of DE as widely as possible. We've made some maybe controversial choices. We decided that an electro-diesel train, like a Hitachi Class 800, is a form of discontinuous electrification. So the GWR trains at the moment, I came here yesterday on a train, it was on electric from Swindon to Cardiff, and then it carried on to Swansea on diesel. We consider that to be a form of DE. And the reason we've done that is that we don't want to miss any opportunities to decarbonise. It may be that diesel is part of the mix in the short term, but maybe not in the longer term. So we wanted to include that as a form of DE. It also, at the other end of scale, if somebody wants to build a battery train that you can only charge by plugging in at night, that is also a form of DE. We consider all those different modes, and we'll come on to modes in a little while. So, I mean, the one thing, just go back to definition, you can see that's a really complex picture, right? So we thought, well, we're not terribly happy with this definition. We need to break it down some more into manageable chunks that we can focus on. So the next thing that we did was to break DE down into 7 modes. So this is like a spectrum. On the left, we have conventional electrification, that's mode 0. And on the right, we have mode 6, which is no electrification, which is the mode we all hate. So, but in between, you can see what a variety of different configurations are available. So I'm going to go through them now. So mode 1 is continuous electrification on the main line, but with the train leaving the main line and going onto a branch line or a siding on an alternative mode of power. Could be diesel, could be battery. So mode 1 encompasses quite a wide range of different possibilities. So right now we have mode 1, I've just mentioned, Paddington to Cardiff and then on electric and then on to Swansea on diesel. That's mode 1, albeit the South Wales main line can't really be considered a branch line, but you get the picture. At the other end of the scale, mode 1 also covers an electric freight, which is doing 99% of its journey under the wires and then going into a non-electrified container terminal on diesel or battery. So mode 1 covers quite a wide range of both existing operation and future operation. Mode 2 is the first, what everybody would probably consider discontinuous when they think about that term. Mode 2 is one short discontinuity within an otherwise continuous system. And we do actually have 4 of these that have been quietly operating in Scotland for the last 40 years. There are some bridges in Scotland which have permanently earth sections. They weren't invented by the Core Valley Lines project. They've been around for a while, and they've been quietly operating since the 1980s. So that's mode 2. Mode 3 is many short discontinuities. So the most obvious example of that is the one that Marie's just talked about on the Core Valley Lines. It's a continuous wiring system generally. There's a few physical gaps, but it's mostly a continuous system. Mode 4 is where things get interesting, because mode 4 is large gaps now in between sections of electrification. And mode 4 is where the industry is going increasingly in the future. It's where Chiltern, GWR, Northern Trains, ScotRail, it's where they're all planning to go with their systems. And I think, speaking to a colleague earlier today, I think Wales and West is heading in that direction as well. So mode 4 is new. I don't believe there's any examples of mode 4 operating anywhere in the world. If I've got that wrong, please let me know in the break. But I don't think we have any in operation at the moment. Mode 5, up to now, all these modes have involved in-motion charging while the train is moving. Mode 5 is static-only charging. So it's electrification islands of static charging. And the most obvious example of that is the GWR trial that's taken place with the ex-Viva Rail train on the West Ealing branch. And then mode 6 is no electrification. That's the thing we're trying to get rid of. So you can see there, hopefully that's more coherent and more easy to understand than our rather mealy-mouthed definition. So I want to talk about whether DE should be temporary or permanent. I don't mean temporary in the sense of a few weeks or a few months, but should discontinuous electrification be the end state goal for UK rail? Clearly, there are a number of good temporary uses for DE. We've been using it on Great Western electrification, on Midland Main Line electrification. Hopefully, we will get authorisation to do more sections of Midland Main Line. We've got bi-mode trains on order there, and when they come into service, they'll be able to provide early passenger benefits ahead of the actual electrification completion. So that's obviously a good use for discontinuous electrification. Also, if you've got a remodelling scheme going in a particular location within the electrification scheme, Electrification should always be the last step in a route modernisation. So it's quite often it can be a good way of stepping over a remodelling scheme while it's going on, and you can use DE there and then electrify the gap when the remodelling is complete. But where we are at the moment as an industry and as a country is we seem to be discussing DE as an end state, as a permanent solution for decarbonisation of UK rail. And I just want to challenge that a little bit, because we're forgetting about one crucial customer, which is freight. The railway was built for freight. Freight's a really important part of the railway, not just railway economics, but actually for society. We're taking a lot of traffic off roads. At the moment, rail freight is lower carbon than road freight, but that may not continue to be the case in the future. Road freight will decarbonise, and we have to move with the times as well. So I'll talk more about freight later on, but I just want to sow that seed of, should DE be the final state of UK rail? So now I'm going to talk a little bit about feasibility. I'm going to talk about system integration, operations, rolling stock. We're going to talk about different forms of charging, what the challenges are there, and then a bit on power changeover. So if you only take one thing away from my talk this morning, I want it to be this, that DE requires a fundamentally different approach to rolling out our projects and our fleets than conventional electrification does. With conventional electrification, there are obviously touch points between fleet procurement and the infrastructure procurement, but there, to a large extent, those two bits of a project can be relatively separate, and the reason for that is that our electrification is designed against common standards, and so is our train. So apart from some basic touch points and basic specification things that need to be right, the two things can go their own way to a certain extent. That's not the case with discontinuous electrification, because the fleet performance has to be matched to the infrastructure capability and vice versa. So what that means is that rolling stock, infrastructure, and operations all have to be stitched together into a single railway system. And that is not the case with continuous electrification. So everybody involved in rolling that system out on a railway, they're going to have to sit down and agree a common goal and a common set of requirements right at the start. And once they've done that, we're going to have to kind of hold to those requirements, because what you can't be doing is changing your fundamental requirements midway through the manufacturing of the train. Right? So it needs everybody to be integrated in a way that I don't think we are at the moment. I think most people in the room would agree this isn't something we get right all the time. We're not great at it. We need to get good at it quickly, because the consequences of not doing that is that we, once again, get ourselves a reputation for not being able to deliver infrastructure projects correctly. And we all know that that's not where we want to be, that's where we've been in the past. So yeah, that concerns me. That's something we really need to focus on. So what do I mean by operations have to be involved? Well, think about how discontinuous electrification works. I know they've been very successful on core valley lines at doing this, been very tightly integrated. As an infrastructure engineer, I need to know things that at the moment I don't really worry about when I'm thinking about the electrification design. I need to know the service pattern. I need to know what the dwell times are. How long have I got for static charging? Right? Where do I need to provide power, and is it available in those locations? Simon's talked about the great grid upgrade. Is there going to be power where we need it, when we need it? What about stabling and overnight charging? Where are the trains going to stable? Where are they going to charge overnight? What's going to happen during disruption when the trains get to their home depot? Then where are they going to charge? What are we doing about service disruption? So a couple of weeks ago, we had a bad incident on Thameslink. The whole system ground to a halt, and people were trapped in trains for a couple of hours. We ended up having to evacuate people off trains. What's that scenario? And unfortunately, that does happen. Hopefully not very often, but it does happen. We have to allow for it. So what does that look like for a battery train? How are we going to be able to keep the hotel power going? Is the train going to be able to move under its own power once the service is restored? A lot of people have talked about battery life cycle and warranty, and it is important. It's important to understand the battery life cycle. What is the warranted performance of the battery? You need to stay within that warranted performance, or you're going to incur significant extra costs on your rolling stock. Anybody who's got an electric car will know that the range of the vehicle goes down in winter and rises in summer. It's no different with a battery train. We're going to have to think about the cold temperature performance. And of course, hotel power on a train tends to be quite high on a cold day, so that's probably the worst normal service operation demand. So we need to think about that. We also need to think about what the battery is going to be doing when it's at the end of its life, not at the start of its life. So what's its range going to be at the end of its life? So if you think about the worst case scenario, what you need to be sizing the whole fleet for is the train at the end of its life on a cold winter's day and a massive disruptive event. And everything has to be sized around that, not around when everything's working well. And finally, we've got to look at power changeover locations, which is something we're still kind of working out how to do. And Marie talked about the problems she had with beacons there. We'll talk a bit more about that in a second. It's important to be realistic about the compromises you make on the rolling stock side with DE, and there are some that you're making. So it's going to cost you more. Your trains are going to cost more. Our current intelligence shows that bi-mode trains are costing between 20 and 50% more than a straight EMU. So that has to be factored into your business case, to your cost calculations, to your whole life system cost calculations. You're likely to get a higher rolling stock OPEX as well, because we've got batteries to replace earlier than but the battery life's typically looking around 10 years, whereas the train is going to have a life of 40 years. So it's going to have multiple battery replacements during its life. That has to be factored in. Also, the disruption of taking trains out to replace batteries has to be factored in. Do you need a slightly larger fleet to allow for that? Maybe. Reliability is a tricky one because we don't know yet. There aren't really, these aren't in fleet service yet, but it may be that they're more complex trains, and we know that typically more complex trains don't have as higher reliability as a very, very simple EMU. So it may be, we'll wait and see. We'll see what the reliability looks like, but it may be that you need to just factor in a bit lower availability into your fleet calculations. Particularly, the tri-modes in particular are significantly more expensive than ordinary EMUs, and obviously the complexity of them. And if you've got a diesel engine, if diesel is part of your bi or tri-mode mix, you are going to take a reliability, maintenance and cost hit. It's worth also saying that manufacturers of trains are increasingly reluctant to put diesel engines on fleets. The diesel engine is, if you think of roll forward to 2030, the diesel engine will start to become a niche product and it will start to cost more. Before I leave this one, I want to just talk about something that really worries me about the cascade process and what DE means for cascade. Let me explain, if you're not a rolling stock person, what cascade is. Railway economics for rolling stock is it hinges on the ability to move rolling stock around the network as the rolling stock gets older. Typically, right now, typically at midlife, about 20 years on the rolling stock, it's on its original route that it was built for. Service patterns have changed, customer requirements have changed, and that rolling stock gets moved on. We buy new rolling stock, bring it in, we move the other rolling stock onto usually a route where the trains are about to be scrapped. That's cascade. That is absolutely fundamentally important to railway economics. Without that, the railway will get more expensive, tickets will get more expensive, there'll be more taxpayer support. So, and the reason we're able to do that is largely we have a railway built on common standards. You might have to make a few engineering changes to rolling stock or to the infrastructure, but broadly, we can move trains around. What is DE going to do to that picture? What happens if we don't have common standards for DE? We need common standards for DE because we cannot limit that ability to cascade rolling stock in future. Just going to talk to you a little bit about modes of charging. The most challenging mode of charging undoubtedly is static charging. Static charging has to take place in that limited dwell time when the train's not moving. and that means your current has to be maximised, your battery degradation is going to be maximised. Anybody who's got an electric vehicle knows that you only fast charge when you have to. Yes, otherwise you trickle charge. This is the picture here is the Viva rail, the GWR West Ealing charging system, and that's using a third and fourth rail in the forefoot. That's great, no problems with current heating there. But if you're using the overhead line to do static charging, you're going to need to think hard about how much current you can push through that small contact patch. And for me, the golden rule with static charging is that us infrastructure engineers cannot be dictating terms to the operations people. We cannot be saying, I'm sorry, but your train has to wait longer in the station to charge. Right? The railway is an economic system. A train that's not moving isn't earning money. Any train operator will tell you, I need my train to be moving, I need bums on seats, I need it to be earning money. So we can't be telling the operators what their dwell times are. They need to be telling us what the dwell times are, and then we have to build infrastructure to match it. Because the goal of electrification, discontinuous or not, cannot be to make the railway worse. The whole point of electrification is to make it better. So, yeah, how do we avoid proliferation of static charging systems? We need some standards for static charging, and we need them pretty quickly because people are procuring fleets right now. So that's something that concerns me. That's something we need to focus on. In-motion charging is a lot easier, obviously, because you're typically going to have more time to do it. There are no dwell time constraints, but your currents are high. You've got your traction current for moving the train, and then you've got your charging current on top. So you need to look at your OCS specification. Is the overhead line up to standard? Is it going to be able to deal with that much current? But also, are your existing traction power supplies going to be up to the job? We all know that there are weak points in the existing traction power network, and there is no spare capacity at certain locations. Those locations are going to need an upgrade, and that's why I say that battery trains are electrification, and that you can't disconnect the two. Battery trains will require upgrades to existing electrification to allow them to operate. I'm not going to say much about power changeover other than it's really complicated and it has to be thought about up front. I did some work on APCO sites on TRU, as Sanjay, who's a colleague of mine in the audience, and it's really complicated. The faster you want to go, the longer the changeover zone has to be. It's all about not having driver workload, too much driver workload. So you need to be away from signals. There's certain OLE features you need to be away from. And there's a risk, actually, we saw on TRU at certain points we were actually discussing moving the changeover off the main line onto the non-electrified branch line to remove that driver workload problem. And what we were ending up doing was potentially adding electrification to the scope. Not removing it, which is the whole point of DE, actually adding STKs of electrification to the scope. So you've got to guard against that. You've got to really watch for that. So again, plan early. Don't leave it. Start thinking about it early. I've touched on freight already, and I just want to focus on this, right? Looking back at our modes, with the exception of mode 1 and mode 2, discontinuous electrification is not an option for freight, and it's not an option today, and it's not an option for the foreseeable future. The laws of physics mean that it is not possible. If you add more batteries to a freight train, it just gets heavier and heavier and heavier, and you're eroding capacity of the freight train. Any freight operator will tell you they will operate on wafer-thin margins, right? So battery freight is not an option, other than going a few miles between sections of electrification. So I worry that DE, all the emphasis of DE discussion at the moment is about passenger, but freight's really important. Remember, the reasons we electrify railways is not for decarbonisation, it's because you get a better railway at the end of it. And that's equally the case for freight as it is for passenger. Electric freight trains can accelerate quicker, get up to speed quicker, and get out of the way quicker. When you electrify freight, you increase capacity for either more passenger trains or more freight. We must offer our freight colleagues a route to decarbonise, because you can bet your bottom dollar that their competition, road freight, is going to be busy doing that. So I'm not sure that DE, although it's great, we need to embrace it, is it the end state, or should we, within our DE schemes, on those mixed-use railways, should we be making passive provision to fill the gaps at a later date when the business case stacks up? I think we should. So, Final slide. I think I'm on time. This is our view of appropriate use cases for discontinuous electrification. A single discontinuity to deal with a problem with no engineering solution. I don't mean, oh, the bridge is going to be expensive to rebuild or anything like that. I mean something where there is no practical engineering solution. Clearly, DE is the answer there. Second use case is this last mile branch line for freight in coordination with continuous electrification on the main line. That's something that, Stadler and other freight companies are already buying bi- and tri-mode freight trains, so some of them are on board with that, but other freight operators are waiting to see what we do on the infrastructure side. They're not going to buy hundreds of replacements for the Class 66, which have got pantographs, unless we can show that we've a route to allow them to decarbonise. Temporary discontinuities we've talked about, that's a perfectly valid use case. Short self-contained routes with no freight and island charging, so that's the West Ealing example. That's clearly a good use. Multiple discontinuities on a self-contained passenger network. The Core Valley Lines is the most obvious example of that. We don't have many railways in the UK that are like the Core Valley Lines, but where you've got that kind of railway, and we have other places in the world, that's a perfectly sensible thing to do. But the last one is the most interesting one, and it's where the industry is going at the moment. It's this idea of multiple discontinuities on a mixed-use railway, passenger and freight. And in my view, that discontinuous electrification should be part of a longer-term strategy to fill the gaps to the extent that freight can then be offered a path to decarbonise, as well as passenger.